Now we look at equation of lines that are parallel. If two lines are parallel, they have the same gradient. So we can prove that these two lines are parallel if they have the same gradient. Alright, so what we're going to do, we're going to find the gradient of these two lines. And if they are the same, the lines are parallel, then we're going to draw those two lines on the Cartesian plane to further prove that the lines are parallel. So what is the gradient of this line? This line is not in the form y equal mx plus c. So this 7x has to go over. So it now will be y is equal to 7x plus 9. So the gradient is 7. This one now. Again, this one is not in the form y equal mx plus c. I think this was supposed to be 14x. Forgive me. So the 2, there's a 2 in front of the y. That 2 has to be removed. So now it's y is equal to 14x over 2 minus 5 over 2. The 2 divides everything on the other side. So y is equal to 7x minus 2.5. So yes, the lines are parallel. This gradient is 7 and that gradient is 7. But let's see it on the Cartesian plane. How do we put this line without the table of value on the Cartesian plane? Well, first of all, we note that this line will intersect the y-axis because C is where the line will intercept the y-axis. So this line is going to intercept this y-axis at 9. We need to find out where it's going to intercept the x-axis. So we know the y-intercept is 9. Or intercept with the y-axis is 9. We put y-intercept. Sorry about that. So remember we said earlier that everywhere in the x-axis y is equal to 0. If we want to know where the line is going to intersect the x-axis, we have to replace y with 0. So in the x-axis, y is equal to 0. So this is y equal to 7x minus 9 plus 9. 0, y is 0 is equal to 7x plus 9. The 9 goes over. Minus 9 is equal to 7x. X is equal to 9 minus 9 over 7, which is 1 and 2 over 7. So this line is going to intercept the x-axis at 9, as here. The y-axis, sorry, at 9. And the x-axis at minus 1 and 2 over 7. This is minus 1.5. It's not going to intersect there. It's like halfway there, I guess. So that's here. So this is the line. This is the first line. So this is the line y is equal to 7x plus 9. Let's look at the second line, where we know that the second line is going to intercept the y-axis at minus 2.5. So it's going to intersect the x-axis at minus 2.5. This is 3. So minus 2.5 will be there. But let's see where it's going to intercept the y-axis. So we say in the x-axis, let's see where it's going to intercept the x-axis. In the x-axis, y is equal to 0. So y equal to y-intercept is equal to minus 2.5. In the x-axis, y is equal to 0. This is 7x minus 2.5. This will give us 0 is equal to 7x minus 2.5. Take that over. 2.5 is equal to 7x. 2.5 divided by 7 is equal to x. What is 2.5? X is equal to. What is 2.5 divided by 7? 2.5 divided by 7 is 0.4. So 0.4 is less than 0.5. This would be 0.5. So 0.4 is just next to 0.5, not too far from it, just there. So the line will intercept the x-axis at 0.4 and the y-axis at 2.5. And this is the line y equal to 7x minus 2.5. And you can see that the lines are parallel. Right, so we prove that. Well, let's look at this example here. If you were asked to find the equation of a line that was parallel to a next line, we have to find the equation of a line that is parallel to a next line. To determine the equation of the line that passes through this point, we need two things to find the equation of a line: the gradient at any point in the line, passes through this point, and is parallel to this line. So we said that if two lines are parallel, their gradients are the same. Two lines are parallel when their gradients are the same. Alright? So what is the gradient of this line? The gradient of this line is equal to minus 2. So we know the gradient of the line that is parallel to this line here, but is passing through this point. The gradient of that line is also equal to minus 2. So using this and the point that the line passes through, we can find the equation of the line parallel to this line here. So y equal mx plus c. Right, so the gradient is 2, y is 5 is equal to minus 2, and x is 3 plus c. So we multiply here, 5, this is minus 6 plus c. 6 comes over, 5 plus 6 is equal to c. c is equal to 11. So the gradient, the equation of the line that is parallel to this line and goes through that point is, equation is y equal to minus 2, we have to put back the minus 2, x, and the c now is 11. So you can see that the gradients are the same. Let's put the other one here. See, the gradients are the same, but they pass through different points. So these lines are parallel too. Alright, so next we look to perpendicular line. Two lines are said to be perpendicular if the products of their gradient is equal to minus 1 or negative 1. What does perpendicular mean? It means 90 degree. And what is perpendicular lines? What is perpendicular lines? If you have a Cartesian plane and you have two lines, this one, if a line is perpendicular to that line, it will cut this line at a 93 angle. Right? So that is what a perpendicular line is. Okay, so example. This example is found on page 331. So we have to prove that these two lines are perpendicular. Okay, that's easy. What is the gradient of this line? We have to put it in the form y equal mx plus c. So it's not in that form. So first the x has to go over. So you have 2y is equal to minus 3x plus 7. Then the 2 has to go, so y is equal to minus 3x over 2 plus 7 over 2. So the gradient is this here. Gradient of the first line, m1, is equal to minus 3 over 2. Let's find the gradient of this line. This 3 has to go over, this 2 has to go over. So 3y is equal to positive 2x plus 5. Then the 3 goes over. So 2x over 3 plus 5 over 3. So the gradient of the second line is equal to 2 over 3. So we got the gradient of the first line, this one and that one. Good. So if we multiply these two gradients, will we get minus 1? They said the product of the gradient is equal to minus 1. So m1 times m2, first gradient times the second one, will equal to, let's see if it will equal to minus 1. m1 is minus 3 over 2, m2 is 2 over 3. 3 cancels with 3, 2 with 2, we have minus 1. So these two lines are perpendicular because the products of their gradient was equal to minus 1. Hold on. Let's put these lines on a Cartesian plane. I showed you how to do it in the previous video. We know the line will intercept the x-axis at, this will be 3.5, the y-axis, sorry, The C is always where the line intercepts the y-axis. The number that is by itself, that constant term, is always where the line is going to intercept the y-axis. So the first line is going to intercept the y-axis at that, and the second line is going to intercept the y-axis at, this will be 2, 1 and 2/3. 1 and 2/3. Okay, so just as you did before, put these line on this graph. Find where the line will intercept the x-axis. So I hope you pause the video and then found this. I would have done the calculation already. So we said this intercept, the y-intercept is 3.5. I replaced y with 0. I brought over the 7/2, it became negative. Then I brought the denominator 2, multiply, and it cancelled. So then I brought the 3 and divide, and that's how I got these. And I did the same thing here. So now let's take the solutions and put them on the Cartesian plane. So first line, it intersects the y-axis at 3.5. So y at 3.5, positive 3.5, yeah. Secondly, it intersects the x-axis at 2 and 2, positive 2 and 1/3. So positive 2, that's here, and 1/3. 1/3 is less than 0.5, so it's somewhere here. Good. So this is the first line. All right, this is the line y equal to minus 3/2x plus 3.5. All right, that's the first line. Second line, intercept the y-axis at 1 and 2/3, positive 1 and 2/3 is what? A little bit more there. Good. So this is where it intercepts the y-axis. It intercepts the x-axis at minus 2.5. Minus 2.5 is here. Unless I did something wrong, this was supposed to intercept this as a 90-degree angle. It doesn't look that way. Let me check to make sure that I did the correct thing. So I figured out where the mistake was. The mistake was in my plotting. It intercepts the y-axis at 1.1 and 2/3. So it's 1 and 2/3 somewhere here, and the x-axis at minus 2.5. So that's where I made the mistake. So we plot, and you can see now the right angle, and that is how you draw a perpendicular bisector. So the next thing we do is, how do we come up with the equation of the perpendicular bisector when given, well, the perpendicular line when given some points only. So that is over here. Good. Let's read the question and attempt to solve it, and then you'll see the solution as we go through it. So given these 2 points, A is minus 4 and minus 3 and B is 2 and 5, determine the gradient of the line. You can do that easily. Solution: the gradient of this line, the line that passes through that point, is y2 minus y1 over x2 minus x1. Let's label it x1, y1, x2, y2. So y2 is 5 minus 3 divided by 2 minus 4. This will give us 8/6, and this will be 4/3. Good. Or we say 1 and 1/3. Next, we were asked to find the equation of the line AB. So We have 2 points. We have A and B, so we can find the equation using any one of those points. So first of all, we have to use the gradient. So using m is equal to 4 over 3 and A or B. Let's use B. There's no negative there. Life is easy without negative sign, so you think. So 5, 2 and 5. Now you're wondering why I'm using 4 over 3 and not the actual fractions, the mixed number. I think it's more comfortable for me to use the 4 over 3. So now y is equal to mx plus c. Y is 5 is equal to m is 4 over 3, x is 2, and plus c. So when you can't cancel a fraction, you multiply the numerator by the whole number. So this is 8 over 3 plus c. Bring that over. 5, 8 over 3. You can use the decimal if you like. Rather than working the LCM, minus 8, 3 is equal to c. 8 over 3 is 2.67. You can just subtract that. Or you can use the LCM like I prefer using. This is 3 times 5. The LCM is 3. 3 5 is 15 minus 8 is equal to c. 8 minus 15 is what? 7 over 3. And that is equal to c. So the equation now, equation of the line is y equal, gradient is 4 over 3x, and the c is 7 plus 7 over 3. And that's the equation of the line. C, determine the equation of the perpendicular line that passes passing through the point B. So there is a line. Let me draw that diagram on this Cartesian plane so you can see what we're talking about. So the 2 points A and B, A is at minus 4 and minus 3. Minus 4, minus 3 will be here, middle here. That's the point A. B is at positive 2 and 5. That is here. So this is the line. A and B. Good. So they asked us to determine the equation of a straight line that passes through, the equation of a perpendicular line that passes through the point B. So this perpendicular line must cut B like this at a 90-degree angle. So let's see if we can determine the equation of that line. So 2 things are needed to find the equation of a straight line. The first thing that is needed is the gradient of the line. We're doing C. The gradient of the line and any point in the line. Do we have we know that the perpendicular line is passing through B. We know it's passing through B, but do we have the gradient for the perpendicular line? Because we need the gradient to find the equation. So we said earlier that if 2 lines are perpendicular, the products of their gradient is equal to minus 1. So if we multiply the gradient of this line and the gradient of the line that is perpendicular to this line, the answer should give us minus 1. Do we know the gradient of this line? Yes, we do. The gradient of this line is 4 over 3. So let's say this is line 1 and the gradient of line 1 is 4 over 3. How do we get the gradient of line 2? Well, we take this over. 3 goes over first, so we have 4m2 is equal to 3 times minus 1. And then the 4 goes over after, so m2 is equal to, so times minus 1. So this will be minus 3. Minus 3. And then the 4 goes over after, so we have m2 is equal to minus 3 over 4. Divide. So let me just show you what happens. If you have a line and another line is perpendicular to that line, in order to find the gradient of the line that is perpendicular to that line, we use this. Or it's a pretty simple thing. If I have a line and the gradient of the line that I have is 1 over 2, 1 over 2, and it said that another line is perpendicular to this line, then the gradient of the line that is perpendicular to this line, we upturn this 2 over 1 and we change the sign. If you notice, the 4 over 2 was upturned to 3 over 4 and the sign was changed to negative. So again, if I had a gradient of 5 over 6 and they said that another line is perpendicular to this line, the gradient of the perpendicular line will be minus 6 over 5. What if I had a gradient that is minus 3? Then the gradient of the perpendicular line, or the gradient of the line perpendicular to this line, which is mine, that has a gradient of minus 3, is, we upturn this here, put that over 1, positive 1 over 3. It upturns and the sign change. Okay, good. So now the gradient of the line that passes through, that is perpendicular, and it's passing through B. So the equation of the line that is perpendicular, the equation of the perpendicular line that passes through the point B. It's perpendicular to these 2 points. So let's find that equation. First of all, we have to use the perpendicular line gradient, which is minus 3 over 4. And we know that it's passing through B, so we use B. B is 2 and 5. So y equal mx plus c. Y is 5. M is minus 3 over 4. X is 2. And plus c. 2 goes with the 4, leaves 2 at the bottom there. So we have 5 is equal to minus 2 or 3 over 2 equal to c. This comes over, becomes positive. Now it is 1.5, right? So let me just put 1.5. 3 over 2 is 1.5. So when it comes over, become positive 1.5. And 5 plus 1.5 is 6.5. 6 and 2/3. You can work out the LCM. So the equation of the perpendicular line is y equal minus 3 over 4 x and 6 and 2/3. 6.5. What am I saying? 6.5. Okay, so what if we wanted to draw this here on the Cartesian plane? We'll have to find out, well, it intercepts the y-axis at minus 6.5. Where does it intercept the x-axis? And in the x-axis, y is equal to 0. So we say 0 is equal to minus 3 over 4 x plus 6.5. 6.5 comes over, it becomes negative 6.5 equal to minus 3 over 4x minus 6.5 divided by minus 3 over 4 is equal to x. So this is where it's going to intercept the x-axis, and that is equal to 8.67 or 8.7. So you can draw that on the Cartesian plane. I don't have space here, sorry about that. Well, you can draw the 2 lines on the Cartesian plane and see if they meet each other at a 90-degree angle. The last question, D, asks to determine the equation of the perpendicular bisector. Now the perpendicular bisector is just like the perpendicular line, but it cuts the x-axis down the middle. It cuts the, not the x-axis, sorry. It cuts the line AB down the midpoint. So if you were asked to find the perpendicular bisector, we have to find the midpoint first. M or x, or whatever you want to call the midpoint, is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, and this will be x1 is minus 4 plus 2, which is 2, y1 is minus 3 plus 5, which is 2 over 2 over 2. The answer is 1, 1. So this is the midpoint, 1 and 1. 1 and 1 is the midpoint. The perpendicular bisector will cut this line here. You have to find the gradient of the, well, the gradient of the perpendicular line is minus 3 over 4. We already find the gradient of the perpendicular line, so to find the equation it will be y is equal to mx plus c. Y is 1, m is minus 3 over 4, x is 1, plus c. 1 is equal to minus 3 over 4, multiply that, plus c, bring that over. 1 plus 3 over 4 is equal to c. 1 and 3 over 4, when you add them, is equal to c. So the perpendicular line, the equation of the perpendicular line, perpendicular bisector, is y is equal to m is minus 3 over 4, x and c is 1 and 4 over 3. Alright, so that's it. Equation of the perpendicular bisector is the line that is perpendicular to this line going through the midpoint.